going to a provider
Go ahead.
who does the QEEG.
Yeah.
And so I have tried to kind of explain in my own way, just like you've talked about research and kind of what's out there in terms of starting with the Q. And I know that we've talked about this before, but I guess what I was thinking is what might be helpful is that if there was like a clip that you would do that kind of says like makes the main points and I could put it like, click this link if you are wondering about the QEEG and why we don't start with the Q.
Yeah.
I'm wondering, would you be willing to do something like that, that I could say, click the link here or
Yes.
something?
Right. What I've just done now, that sound you heard a moment ago was me starting a recording for this exact purpose. So are you okay if I record
Yeah.
this?
Yes,
Okay.
absolutely. Yes.
All right. Very
Yeah.
good.
Mhm.
So, one thing, so the question is, what about the quantitative EEG? And it would appear if you're doing internet searches, you'll see that on no websites will you find that the quantitative EEG can identify any diagnosable conditions except seizure disorders. They will imply that they can see where the problem is, what the problem is, and resolve it. They will imply that they can't say it. Why they can't say it is that there is not any clinical trials that have ever been replicated of any decent sizes that has found any diagnosable conditions of major depression, PTSD, from the EEG alone. And what those methods are good for, and by the way, not better than BrainPaint, because they've been compared with this particular methodology that BrainPaint automates, is they is that they've never found them to be better. And what they can't also do is they don't come up with they what they've been doing is they do a quantitative EEG and then they also do a symptom-based evaluation. And increasingly, protocols that I've seen coming back from them look more and more like our particular protocols, with the exception they never come up with alpha theta protocols, which are the most evidence-based protocols for stress-related disorders like PTSD and things of that nature. Not that there is that neurofeedback is ever a medical treatment for any diagnosable conditions, but you will not see that in any of their websites that they're saying that. And it is not the most used method in the world. In fact, only about 5% of published studies use quantitative EEGs. And in my experience, one significant cause of that is I've tried to train clinicians in the use of that in universities or with research associates. And the learning curve is too steep. It takes about 2 years to learn how to put anywhere from 16 to 256 sensors on someone's head and get correct impedances and then to properly artifact the data when there's things that are not actually EEG, you have to cut that out of the signal. And so the learning curve is so steep that it's very difficult to even train research associates and also to adequately replicate results. What brain paint is, and here's the other thing too, I would say that, why is it that there's skepticism around neurofeedback is that all neurofeedback systems are not alike. That what we've found to be absolutely critical to practices is that you have services like this, where we have, today about 30 clinicians are going to be cycling through the room asking for some clinical questions and also equipment that can further automate when should I do something different with the client, or what is the statistically what is the best approach for people who completed an assessment like this. The method that BrainPaint automates is called the Scott and Kaiser modification of the Peniston protocol. So we published a study back in 2001 with the UCLA Neuropsychiatric Institute, where we ran a polysubstance using a population that had a vast array of comorbidities. And we found before we even conducted the study, what were the most effective protocols for the largest population of people. And we found this combination of beta and SMR and or alpha theta training. We ran a bunch of people through that method and found a very large effect size on all domains of psychologic functioning per the MMPI, on the test of variables of attention and the ANAM, which we didn't publish, that had significant improvements in cognition as well. We had to keep the size of the paper down. Retention in treatment from relapse as well for the year and a half of accumulated follow-up, where we contacted everybody in the entire cohort except 2 in the control group and 1 in the experimental group, and nearly doubled the success rate of addiction treatment. Well, after that, I made BrainPaint to automate that procedure, and then we collect de-identified data from every session that's ran anywhere on the planet for further quality assurances and improvements to further refine the protocols based on the evidence of what we're seeing. And so that you have this standardized approach that helps with about 80% of people. As I said before, we can never promise anyone any results for any modalities ever. But when we keep statistics on that, we can see with tens of thousands of people and 8 to 10,000 people a month receive BrainPaint, and we're continuing to add more intelligence into the system with further guides and things of that nature that will give clinicians fewer things to have to remember what to do to automate. Another thing too that's happening is a lot of people are getting these devices they slap on the forehead with these dry sensors and say we're doing neurofeedback as well. I wish they worked in my tests of every one of them. I'm hoping one can read brainwaves, but there's a phenomenon called the signal to noise ratio that I found in others as well to be too impaired, where there's too much noise. If somebody has maybe 4 times the normal amount, we may be able to read some alpha in that signal, but people can think that they've done neurofeedback. Or there's methodologies that people are trying to employ that have way too many moving parts for a clinician to even learn. With assessment tools, which is why I made BrainPaint, was that I had trained over 3,000 clinicians on 3 or 4 other manufacturers' equipment, and it was just too complicated. One method, the tries to read this really slow frequency that's 0.0001 hertz, and with that particular, when you get down to 0.1 hertz, you have to check impedances. They have to be within 1 k ohm difference between all sensors. So if you have 3 sensors on their head, 1 or 2 on the ears, 1 on the scalp, or 2 on the scalp, each sensor has to be within a k ohm of impedances, or you're just giving feedback on galvanic skin response. Or if a sensor has to be sintered, what does that mean? That means like corroded, a silver sensor that's corroded with silver. If it gets even a scratch in it, you're now only giving feedback on galvanic skin response. So there's so much room for error. And the reason we choose the sensors that we choose, and the reason we've built all the guides into the process, because there's so many ways that things can go south. And so that's essentially what BrainPaint is. And we also have to have built into your products that if a sensor is going bad, we don't expect anybody to be an IT person that will know how to connect your machine to an internet, or if a sensor is broken or your gray cable's broken. You have to have a number you can call during business hours, 9 to 5 Pacific time, and get that resolved and teach you how to keep your practice going as well, so that you're not rescheduling clients for weeks, waiting for other things to arrive or what have you. And also, we have an ability to track if a practice is doing something that's not what we train them to do. We collect de-identified metrics on that as well. So we can go in and specifically train somebody, because they can't know what they don't know, but we can know what they're supposed to know and go in and train individuals. So we have these standards built in to our equipment that ensure the quality of our brand, essentially. And most other equipment, they just purchase, and if in my experience with other equipment, 40% of the time it would just gather, I'm sorry, 60% of the time it would just gather dust. But if somebody was very left brain analytical, computer scientist like, they were the only ones who would be able to adopt the technology. But my experience, clinicians tend to be more like artists. They're more of a, you'd think of as a right-brained person, and they can outsource their worrying about the equipment to us. We take that on, and we worry for you if a sensor is broken in your clinic, and you don't have to. We can teach you what you could do to keep your practice going with maybe placing an ear sensor on the scalp in some cases. So how to do that. Anyway, I would say those are some of the largest differences of what we have and some of the differences between quantitative EEGs and research. And I will email me, Gina, Bill at brainpaint.com, or anybody else if you want the study that looked at QEEGs and how little they're actually used in the literature, and how small the studies tend to be. All right. That's it.
Yeah, that would be very helpful, Bill. And I concur because, with the whole idea that using other systems that are out there, I've used a couple of them, and I know that the learning curve is really steep on that, and it also kind of requires that ongoing kind of like a trial and error, and the clinician to kind of keep adjusting a lot of the thresholds and things like that, which I found that difficult. For a person who is asking, well, if you're not looking at my brain, then how do you know what exactly that you would train, or how would you go about it? How would you answer that?
Yes. Well, the most important thing to know is, well, this is actually, it would, to really understand this answer would require a degree in complex adaptive systems. But what we know, what physics knows about complex adaptive systems, those are systems that have three or more parts that influence each other and have feedback loops built into them. That's our brain. That's us all as well. And so with these systems, when you given feedback to those systems, what ends up happening is those systems automatically self-regulate. They improve stability. But when you then try to look to those systems to see how they're changed, we have not solved what's called the three body problem, introduced by Isaac Newton 340 years ago. Now, we've not solved this problem when you have three or more variables that influence each other. When you give feedback to them, you can't tell what that system's going to, you can't tell what the impact of the specific feedback was. You can see the overall system will stabilize in their orbits, or in this case, mood regulation or cognitive regulation. So you can't look to a system like this because they're what time of day it is, what medications a person's on, how long it's been since they've eaten, if they have any blood sugar levels, how warm they are, how cold they are, how anxious they are, how calm they are, how much they've slept. I could go on and on and on with all the variables that affect your brain waves from moment to moment. But the beauty of it is the brain waves are just the electric noise that our brain's producing that's related to the functioning. It is not the function. We can see the effects of it in one session. There's numerous studies that used our PZ alpha suppression, part of the Scott and Kaiser modification of the Peniston protocol, it's called. We can see how the PZ alpha suppression, they did a baseline fMRI, one alpha suppression like we do in alpha theta sessions with BrainPaint, and a post fMRI, and saw this brain network that makes people feel miserable a lot of the time starts to activate more, like where less misery is felt. Now, it rebounded back in one session, which is what we see when somebody does one session. They might have some results that might last for a couple days. After between 5 and 8 biweekly sessions, we tend to see ongoing improvements with them. But you can't look to the EEG consistently because there's so many variables that would obfuscate the problem. When we do solve the three body problem, we'll be able to see precisely what is. We may even be able to see what somebody ate on a Sunday 10 years ago when we solve the three body problem. We'll be able to weather predictions, 5 years into the future, not just 10 days as well. So those are some differences.
So in a way, kind of your explanation is like looking at the functioning, how the brain is functioning is a more credible way of approaching the training method as opposed to a QEEG where you get a slice of how the brain is doing in a moment in time, which could be influenced by so many different variables like sleep or medication and things like that. And so to approach it from that window that says we're looking at functioning, and there are certain ways that we can approach how a brain best functions, and that's kind of how the brain paint system operates. Would that be accurate?
Exactly. It precisely, yeah. And and what we're talking about there for the more scientifically minded people are state versus trait differences, where there's EEG may reflect elements of a state, but it can't really say much about the underlying traits. So there's three traits primarily, and this is simplified, but there's three primary root causes that brain paint can look at overall how somebody's brain is functioning. That's related to how we feel and how we think. There's underactivation when somebody's brain is too like sleepy. And there's questions, a bunch of questions that we ask about all these three states. There's another one, overactivation, where somebody's brain's running too fast. Like it's like it drank too much caffeine. Like if any of us drank a half gallon of caffeine, we'd be very over aroused and having lots of negative symptoms. And then there's the stress-related disorders. To what extent has our brain gotten conditioned from fears and insecurities by events in the external world that our alpha theta training could address? And so then BrainPaint comes up with a cocktail based on these traits and patterns that often is well run in family systems, that can give them an initial starting protocol based on symptoms that we're asking about that you cannot see in the EEG. Absolutely impossible to see these traits in the EEG. It would be wonderful when we do solve the three-body problem, and I believe we will, that we will be able to see it. I'll likely be one of the first to do it because I've been obsessed with this since I was 11 years old, actually. And hopefully we will, but right now we can't see those. So when we can find these root causes, it's called the Yerkes-Dodson arousal law. There's a beautiful study in PNAS that was published about 5 years ago with where they took a group of Air Force pilots who would ordinarily flunk out of school because they would crash in the simulators because they were over aroused. They're very aware of the Yerkes-Dodson arousal law. If people's brains are too underactivated, their performance will be diminished. If they're too overactivated, too aroused, their performance will be diminished when they're optimal. So they found a group of people who are very under aroused through a series of tests. They then trained them with our sensory motor rhythm to teach their brain to slow down more. And they were able to move them to the optimum level of functioning. And through physiologic measures of heart rhythm and pupil response, plus, most importantly, the flight simulators, they did better than the average population after their brain learned to balance its arousal states. We know quite effectively since 1969, when Barry Sturman published his first research with cats, that the sensory motor rhythm can teach this reduction in arousal, particularly for those who are stuck in more over-aroused states. And those who are stuck in under-aroused states with major depression, the software will come up with these primarily beta-heavy protocols and increasingly eliminate errors from bias that clinicians can make through the statistics we collect. Brian has had his hand up for quite a while.
Thanks, Bill.
Well,
Thank you.
yes. Hi, Brian.
Yeah, this one shouldn't take very long. I'm trying to get the beta version that you were talking about a few moments ago. But when I go to my everything 115 point screen, I don't see under the USB transfer file, there's nothing there.
Yes, you have to double right. Well, you have to double right click. You don't click that option. It's set above the client list. Go click exit and bring your client list back up again, Brian.
Okay. Okay.